Okay, sweet. You guys did an awesome job here. Yes. Oh, so good point, Delia. It does look weird because there are two A's, C's, and B's on the picture, but remember the capital A, B, and C are the angles, and the lowercase represent the length of the sides. So let's see. Sine A is the opposite side over the hypotenuse. Cosine is the adjacent side over the hypotenuse. Tangent is the opposite over the adjacent. Looks good. That's all from this angle right here. Now down here we're looking from angle B. Opposite over hypotenuse looks good. Adjacent over hypotenuse and opposite over adjacent. Nice. Good job, guys. I'm impressed in the short amount of time I gave you. Nice. Alrighty, so we are going to continue with trig ratios. Just to finish up reviewing, we definitely got a good start last time, but ran out of time. Let me put those two links in the chat. These are two new ones, just extra. So if you want to keep watching some more stuff after we get done here, that's what those two links are for. All right, so as you remember, this is what we just reviewed on that warm-up screen. If that was confusing to you, definitely make a note of this page, and that will explain again how we got those ratios. So remember, when we're doing trig ratios, you need how many things in the trig ratio? Let's review that really quickly. So in these ratios here, yeah, sorry, Precious. That's okay. I did get it up there late. That was my fault. I know. I thought I had it in there, and then I went to log in, and I'm like, oh, no, I don't have it in there. So I'm sorry about that. So how many things do you need in order to write a trig ratio? Let's review this from last time. You need two things in the ratio, but okay, so yes, let me clarify. Like if you were going to write out the whole equation, so if I had sine A equals A over C, how many things do I have to plug in there? There you go, that's what I'm looking for, 3 things. Now let's break it down a little further. Out of those 3 things, how many of those things are angles and how many of those things are sides? Yes, good, Sarah. 1 angle and 2 sides. Good, Stephanie. Good, Delia. Good, Nora. Yes. So we need 1 angle and 2 sides in the equation. You can only be missing one of those 3 things, right? Because to solve it, we have to use algebra. We can only have one unknown value. Okay, so we left off here last time. We already did the first question on this screen, and so I'm going to start on the second question on this screen. Okay, and it says find the length of FD. So I'm going to put an X on FD to show that's what we're looking for. At the end, we're going to round to the nearest hundredth. So how do we start these? Anybody remember? Oh, Brian's got it down. Except, no, it's not going to be tangent though. But that's a good try. Okay, yes, there you go. Well, that's why I back up just a little bit. Let's take it a little slower. Yeah, we want to label our sides, right? So let's start with that. So how do I label my sides? Like hypotenuse we can do, right? Good, well, so hypotenuse is always going to be across from the right angle. So I'll put an H over there. As far as my adjacent and opposite sides, though, what do I have to think about? How do I determine opposite of what? Now I see Brian and Ben both put F. Right, there you go, Ben. So you have to look at the angle. Now, are you ever going to take sine, cosine, or tangent of the right angle? So would I ever do sine, cosine, or tangent of angle E? Never. That's right. You never would, okay? So it's either angle F or angle D, one of the acute angles. And you guys are right. We're going to go with angle F here because we know angle F. Okay, so that's your big clue there. So that looks like it's making sense to you guys. So which side is opposite angle F? Good. DE. Yes, exactly, Delia. And then the side that's left has to be the adjacent side. Just remember, adjacent means next to, so that side is next to angle F. It helps form angle F. So what three pieces do I want? You guys already told me. Let me grab I'll grab blue and we'll circle what we know. We already know angle F, so we definitely want to have that in our equation, right? What else do we definitely want in our equation? So we have, remember, we have one angle and two sides that we need. We already have the angle. We have angle F, which is 39 degrees that we want in our equation. Okay, FE and FD. That is correct, Brian. And the reason there is we know FE and we need to find FD, right? So that's how you know. Okay, so you look at these. This is your combination, what you want. Now what we do is we look at the sides that we chose. We chose side FE and FD, and we look and we see what letters we labeled those with. So FE has an A for adjacent, FD has an H. So remember SOHCAHTOA, or whatever other mnemonic device you use to remember this, but somehow you need to remember that combination. Which one am I going to choose? Yeah, cosine, because it has the adjacent and the hypotenuse in it. Those are the two sides we're using. Good, good. So we're going to say cosine what? What always goes next to cosine, sine, or tangent? In this case, we're choosing cosine, but what always goes next? Good, Brian. Our angle F. And I'm just going to write it with the letters for now, and then we'll plug in what we know in the next step. Okay, on the other side, we always have a ratio, so you can automatically write a fraction sign there. And the cut tells you adjacent goes on the top and hypotenuse goes underneath. So our adjacent side is FE. Our hypotenuse is FD, right? How are you guys feeling about that? This is critical that you can get to this point. Are there questions? Please ask. Don't feel shy. How are you guys feeling about that? Can you feel like you can get there on your own? Okay, no problem. Can you guys explain a little bit about maybe what is confused, or grab, let me turn whiteboard privilege on. Point to maybe what part where you got stuck, and I'll re-explain. Or jump on the mic. So let me know if you got stuck, if you got stuck here, and understanding how we knew we needed F, side FE and side FD, or maybe let me know how you knew to choose cosine, or were you stuck here on how we plugged things into the ratio? What part? Where did you get stuck? So far, everyone's, for the most part, pretty good, but I'm just going to pause here to make sure. And we're going to do a couple more examples too. How do we find the sides? Okay, so if we look at our triangle, one thing we mentioned last time, which I forgot to mention this time, is the trig ratios are only going to work if it's a right triangle. Yes, you're right, Brian. Yes, you could do that. You could do that. Exactly. You are right. You could find DE and then use Pythagorean theorem. Yep. It'd just be an extra step, but you'll get there. No problem doing that. Yep. Okay, so first of all, trig ratios are only going to work if it's a right triangle. Okay, and the right angle is going to help you identify hypotenuse. So just like in Pythagorean theorem or whenever we talk about a right triangle, the The hypotenuse is always the side opposite the right angle. So that's how we need to label that with an H for hypotenuse. The opposite and the adjacent sides are going to vary. So sometimes this might be opposite, sometimes this might be adjacent, or sometimes this might be opposite and this might be adjacent. It depends on the angle that you need. We went from angle F because we had information about angle F. And so that's how we knew to go from that angle. And so it's kind of like hypotenuse. You say, okay, well, what side is opposite that angle? And that's where you put the O for opposite. It just means opposite the angle, opposite the acute angle that you need. Okay? And then once you have everything labeled, you look for the two sides that you have information on. We knew 20 and we needed X. And so we knew we needed the combination of A and H. So if we look at SOHCAHTOA, A and H, that combination only happens with cosine. And so that's how we need to start writing out the ratio for the cosine. Okay? And then it's always cosine of your angle. Oh, no problems, Precious. It's recording, so if you missed anything, you can go back. You haven't missed a whole lot. We're still on the same problem. And then we have adjacent over hypotenuse. Yes, yes. So FE is our adjacent side. Yes. So let me maybe write it like this. I see, let me see. Okay. So we have adjacent over hypotenuse. So if we look at our adjacent side, I know all these letters are getting confusing, I think. The adjacent side, another way to name the adjacent side is FE. And another way to name the hypotenuse is FB. So that's how I had written it out. So the adjacent side is this side right here between F and E. Is that kind of where the confusion is coming from? Does that clear that up? Nice, Delia. There you go. Oh, well, just because here, okay, so Sarah, let me go to the next step. I think that'll help you here. Okay, I'm going to, let me move this stuff over so I have some room. Okay, now I'm going to plug everything into this. I'm going to put in my numbers. So I know angle F is 39. I know FE is 20. And I know FD is what I'm looking for, so I'm going to put an X there. So the reason that we needed to put this in, even though we knew it, is see how I have 1, 2, 3 things that I have to plug in, and I can only be missing one of those 3 things. So if I had chosen O and H, how many things would I have been missing? So in other words, if I had done cosine, that's not going to work because I'd be missing 2 things over here. Okay? So that's why we have to go with one side we already know and one side we need to find. Okay, cool. Good. Now we're cooking. Okay. So what you're going to do from here, if you know the angle, now in a second here we're going to do some problems where the angle is going to be missing, and then it's a little bit different. But here we know the angle. So you're going to type this in your calculator, or you're going to grab that trig ratio chart. But most everybody, you guys have access to the internet. I would just go ahead and use your calculator or use your computer. Type in cosine of 39, and be sure not to round it more than 4 places. What would you get? Are you guys getting 0.7771? Oh, nice. Well, see, if you use your computer, then you can just copy and paste it into the chat. You can get really accurate. Okay? And then you have 20 over x. Okay, algebra skills. How do we solve for x here? Yes, Ben. Now it's definitely okay to round. My caution would be don't round this to 0.8, for example. That's too much. Okay, keep 4 decimals there. Oh, thank you, Delia. I hate when I do that. I was having a great conversation. I just wish you guys were in on it. Okay. All right, so what I was asking, I think probably where I turned my mic off, I don't know. I was asking how we solve it from here. And I was telling Noor that I'm glad that you put in there to multiply by 20 because that's a really common answer, but it is not the right one. But I'm glad you did that. That's why I'm asking right here, what did you do? Let me back up. Okay, so since I was talking to myself. Okay, I was right here when I asked, what do I do next, okay? Now the reason that you don't multiply by 20 is because 20 is in the numerator. If I multiply by 20, is 20 going to cancel out? Right, Ben. It's going to become 400 over x, and I still have that fraction. That's what I'm trying to get rid of. So what you want to do is multiply by the x. So Ben had it right. Okay, and that's what I was showing you guys. So we'll always multiply by whatever's in the denominator, whether it's x or whether it's a number. Sometimes you'll have a number down here, and sometimes you'll have a variable down here. But either way, you're going to multiply by whatever's in your denominator on both sides. And what that's going to do is get rid of your fraction. So we're going to cross out the x's, and we just have 20. Okay, and then over here we have 0.7771. Now how do I get x by itself? How do I get rid of the 0.7771? So it's x times that. I want to do the opposite of that. Good, Stephanie. So you got to divide by 0.7771 on both sides. Excellent. Okay. So I have x equals, and it's kind of surprising, but you get 25.74. And now, since this is our final step, this is x, it's okay to go ahead and round to the nearest hundredth. So that would be where I would leave my answer. Okay? So to this point is the geometry part. Here on down is Algebra 1. Okay? So just remember, that's my tip, is whatever your ratio is, if you're missing one of those pieces in the ratio, you're going to go ahead and multiply by your denominator on both sides. Okay? All right, now we're going to do a couple here where we're missing the angle. These get a little trickier. So the setup is the same. Where it's going to change is after we get to this point, the steps below that are going to be different. Up to here, though, the geometry setup is going to be the same, so that's the good news. Okay, so you don't have to start all over. So we're going to go through the same process. All right. So just like the last problem, the best place to start with these is to label your sides, opposite, adjacent, and hypotenuse. So where's the hypotenuse? We can always get that one, right? Because they're only going to be on right triangles. We know where our right angle is. Excellent. BC. Good. Okay, now, remember, to label the opposite and the adjacent side, I have to first know what angle I'm going to do. Now, I'm never going to use angle A here because angle A is my right angle. I'm either going from angle B or angle C. Which one? What do you guys think? How would I know which one to look from? Read the question again. Good, Nor. Perfect. Angle C, because that's what I'm looking for. The question says, what is angle C? So in this case, that's my x. I'm going to actually be looking for the degree measure of that angle. So from angle C, what's my opposite side? Good. Good, guys. Excellent. So this is my opposite side, which means AC has to be my adjacent side. Okay? Now we write out SOHCAHTOA and we figure out which one of those we're going to use, sine, cosine, or tangent. So which one do you think, and why? Okay, let's see. We have a tangent and we have a sine. Let's see, which one? Let's try. I'm going to be devil's advocate. Let's write out tangent. Okay, just to see. I think this will help solidify this idea in your head, okay? If we try tangent, we always put our angle in next. We're going from angle C, and then the ratio is the opposite side over the adjacent side, okay? Let's plug in what I know. I don't know angle C, so I have to leave that as angle C. I know the opposite side is 5. Oh, and I'm missing the adjacent side. Is that enough to solve? Do I have enough pieces of my puzzle to solve that? Ah, see, so Precious says, oh no, now I see. So no worries, okay? So if you accidentally choose the wrong one while you're, getting the hang of this, you're going to figure it out. When you get to this step, you're going to just pause and say, there's something wrong there, okay? So that'll give you the hint. Oh, okay, let me go back and look at that again. I did see so, and that's the correct one here because I know my opposite and my hypotenuse, and I'm missing my angle. So those 3 things I circled in like the pink color there, those are the 3 things I want to make sure that I include so that I'm only missing angle C, because I only want to be missing one of the 3 things, right? We have one angle, we have 2 sides that are included in every single ratio, and you can only be missing one. So we're going to go with sine. So we're going to say sine of my angle, which is angle C in this case, is the opposite side over the hypotenuse. Yeah, Delia, so again, you know what? That's the challenge with this, is kind of getting the hang of, okay, how do I know whether it's sine, cosine, or tangent? So don't stress, Delia. If you chose ka, you'd plug it in and you'd try to go with that, and you'd say, I got stuck. What's the deal? And then you could go back and take a fresh look at it. So my opposite side is 5, and my hypotenuse is 16.2. Okay? So I can solve this. I'm missing one thing. I know the other 2 things. But remember on this last problem that we just did, how I said, okay, from here on down, it's going to be different. So that's where we are now, okay? We're at that point. We've plugged everything into our trig ratio. We've plugged it into sine. Okay, this one isn't going to work. So now it's different than how we solved the last one. So remember on the last problem how we were missing the denominator. So if you're missing one of the numbers in your trig ratio, you're going to do what we did on the last problem. Remember, my tip was to always multiply by whatever's in the denominator. Well, in this case, we know both of these numbers here in the ratio. We're missing the angle. So here is what you do. You probably haven't done anything exactly like this before. You're going to go ahead. Now this part you've probably done before. You're going to divide this. I know it looks strange to have a decimal inside of a fraction, but you can have that. And just remember, when you use your calculator, you want to put the numerator in first. So you want to do 5 divided by 16.2. Good, Stephanie. And Stephanie is also correct in writing that out to 4 decimals, 0.3086. Did you guys all get that? So do 5 divided by 16.2. Good. Okay. Now, what you're going to do on your calculator, if you look at your calculator, you will see this button. It's called, and I should have left myself a little more room. Let me actually do that really quick. I'm going to move this over. Hang on. Just so you can see what I'm writing here a little bit better. Let me scoot this over. You want to use the sine inverse. It looks like the sine with an exponent of -1, but it's actually called sine inverse. So do you guys see this on your calculator or your computer, which, whatever you're using for your calculator? If you have an actual physical calculator in front of you, a lot of times it will be on the sine button, but up above it in like a different color. So you might have to hit like the second key and then your sine button or something like that. Okay, so Will, good tip. So he says press the inverse button first if you're using Windows. Yep. Okay, so that will be part of the challenge, is figuring out your calculator. Okay, but you want to get sine inverse in your calculator, and sine inverse and sine are opposite operations, just like multiplication and division are opposite, or addition and subtraction are opposite. These undo each other. Okay, so what you're going to get on the left is just angle C, which is good, right? That's where we want to be going, because that's our question, is we're trying to find angle C. And of course, algebra rules. If you do sine inverse on the left, you have to do sine inverse of the right. So angle C, all you need to do in your calculator is hit sine inverse and type in that decimal that we just got, 0.3086. What do you guys get? Good, 17.97. Or 9.8. Would it round up to 9.8? I'm getting 9.8. There you go. Okay. And that's okay. If you're 9.7 and it's 9.8, you're probably going to be all right there. Okay? Excellent. And this is an angle, and so we actually have a degree measure up there. So angle C is 17.98 degrees. Now, it doesn't specify here, but a lot of times, usually with an angle, we'll round it to the nearest whole number. So like I said, the rounding on these, you really have to pay attention to the directions. Most of the time, though, you'll just see us round that to 18 degrees. Okay? All right. And one thing I should mention back on this problem, since this was a side, we should have put M for meters. So make sure you put degrees if it's an angle, or if there's units given, write the units next to the side length. Okay? All right, let's try this last one here. It says, Anna has leaned a ladder against the side of her house. If the ladder reaches up to a point that is 6 meters high, and the bottom of the ladder is 2 meters from the wall, what angle does the ladder make with the ground? Okay, so let's sort this problem out. So think about this triangle. Okay, it says Anna has leaned a ladder against the side of her house. So think about what side of the triangle would represent what. The ladder is leaning against the side of her house. So this side is the ladder. Yes, Delia, and it is a right triangle. Okay, so here's your ladder over here. Good. The vertical side has to be the house. The ladder is leaning up against the house. What's the bottom side representing? Yeah, the ground. Excellent. Okay, so there's our three things. Ooh, Brian already has the answer. 72 degrees, he says. Okay, let's see if he's right. 2 meters, okay, yes. So the ladder reaches up to a point that is 6 meters high. So it's saying up here at the top of the ladder, that's 6 meters high. So that means that this side of the triangle has to be 6. Does that make sense? The top of the ladder reaches up to a point that's 6 meters high. The bottom of the ladder is 2 meters from the wall. So here's the bottom of the ladder, and it's 2 meters from the wall. So obviously this triangle is not drawn to scale, but those are the lengths, okay? So 6 meters high, 2 meters from the wall. What angle does the ladder make with the ground? So here, this is where these word problems you'll mess up. Just read your question now. Ladder and the ground. You're wanting to know where those meet. What's the angle? So this is the one you're looking for, not this one. This would be the ladder and the house. Okay? So that's how you sort out what you're looking for. So that's our x. We're trying to figure out that angle right there. So same process, right? That's what I'm saying. If you practice enough of these, you know, other than the algebra part, getting it set up is always going to be the same. So we're going to label our sides now. So which side's the hypotenuse? Good. Excellent. I love it. Ooh, that's nice. Everybody's answering. Excellent. What side is opposite? Good. You guys are getting it because we're going from angle X, so the house is opposite angle X. Okay, so again, remember to label your opposite side, you have to first ask yourself, okay, what angle am I using? It's this one here that we're looking for, so I want to go opposite of that angle. And then the side that's left has to be adjacent, right? The ground's the adjacent side. Okay, what are my three pieces? So I need one angle, I need two sides. So just type them in. What three things do I want? What's the angle? What are the two sides that I want to include? Good. Good answers. Good, Brian. Good, Will. Good, Nor. So I write out SOHCAHTOA, and Brian's already telling us it's tangent, which looks right. Good, Sarah, because we know the opposite side is 6. We know the adjacent side is 2, and so that tells us we want to include the opposite and the adjacent side in our ratio, and so that narrows it down to tangent, because over here you have opposite but not adjacent for sine, so we don't want to use that one. Here we have the adjacent side, but we don't have the opposite side, so we don't want to use cosine. Okay, so that crosses those two choices out. Now, same process. We write the tangent, and then we write the angle next. We don't know the angle in this case. It's x. And then over here, we write the ratio, the O and the A. Okay, O is in the numerator, A is in the denominator. Now we plug in what we know. We don't know the angle, so we leave that as x. We know the opposite side is 6 and the adjacent side is 2. Okay, we went through that pretty quickly. How are you guys feeling up to this point? Give me a smiley face if you feel comfortable with this. Okay, good. I'm seeing lots of smileys. Good. Now, if you're not, don't stress. Just keep practicing and definitely come to tutor time. And Monday, we're going to kind of switch gears and talk about special right triangles. But Tuesday, I will have a tutor time. As a side note, next Wednesday through Friday, I'm going to be out for more testing. So we will have Monday and then a Tuesday tutor time next week, okay? Excellent, Delia. That's the next step. So you want to divide. So if you know both of the numbers in your ratio, you take 6, divide by 2, you get 3. And then we are trying to get x by itself, so we have to get rid of the tangent. The tan inverse is what undoes the tangent. And so we want to do the tan inverse of both sides. Okay, so the tan inverse and the tangent undo each other, and we get x. And I know you can't really see that, so I'll rewrite it. Tan inverse of 3 is what's going to give us our answer. Good, you get 71.57. Awesome. And that's right, Brian. Usually if it's an angle, we round it up to the nearest whole number. And let's see, yeah, it still doesn't specify in the directions, but that is usually what we do. So 71.57, which is approximately 72 degrees. So you were right, Brian. Nice. Brian's fast on the draw on these trig problems. All right. So we have 6 minutes left. What I'd like, there are 5 problems up here. Can I have some volunteers to solve these? All right, Will and Ben and Nor. Let me write your names up there. How's that? So how about Will, Ben, Nor. 2 more? Oh, Brian, awesome. And anybody want to try that last one? You are, Gemma. You are. And I'll guide you through it if you want to give it a try. Oh, nice, Precious. Okay, cool. So yeah, if you guys are still a little cautious about that, okay, that's actually very normal at this point. So don't feel bad if you're kind of like, I think I get it, but I'm not 100% sure. Just practice along with and go for it, guys. If your name's on the board, go ahead and start writing up there. I'll stop talking, and we will see how far we can get in 4 minutes. We might not finish all of these, but that's okay. And Nora, Brian, and Precious, I know you guys kind of have to wait for Will and Ben, and they're super fast, so I'm sure they'll be getting it done quickly, but you could set up your trig ratio there at least and have it ready, and that way once you find those other two sides, you'll be able to plug those in. All right, guys, so Will has finished the length for CB, and he got 6.06, which is correct. So double check and make sure you guys understand that and that you are getting that. So 6.06 for side CB. Yes, give Will a round of applause. Nice work. And give Ben a round of applause because his answer of 16.18 is also correct. Very nice. Excellent. So now Nora, Brian, and Precious can finish their answers really well. Well, I tried to, Ben. I don't know. It's still sloppy with this, with Illuminate, but I think you can sort of read it. Very nice. Yes. Nor and now and on this down here what they're wanting is just the ratio. So they are actually just wanting you to divide the sides and say what that decimal comes out to. So you actually don't have to solve it because you already know the three pieces. So what the directions, if it just asks for the trigonometric ratio, it just wants you to find out what that decimal is because the ratio is just the fraction part. So I know sometimes that's the hard part, is understanding the directions. Excellent. So yes, Nora, you got it. This is the trig ratio of sine of A and then cosine A, so you just do 15 divided by 16.18 and get the decimal there. Excellent. 0.9272. You guys are rocking this. Very nice. And then this one, you would just do 6.06 divided by 15. Very nice, guys. Sorry, we went a few minutes over. If you have to go, I understand, but yes, perfect. And then you just add a 0 there to keep the 4 decimals. I know, we have to be technical there, but excellent. Beautiful job. Give Nor, Brian, and Precious a round of applause as well. Very good. Thank you guys all for volunteering and jumping on the whiteboard. Oh, that's true, Brian. Yes. And I'm glad you're making that connection. Yeah, if you do cosine of 22, you should get the same thing. Yes. Good point.